Okay, section 7.4, we're talking about roots and square roots. We also have to talk about roots that aren't just squared. So we need to talk about roots where we have the index, which is the number that's in front of the root, that's a number other than 2. So it might be a fifth root or a third root or just your average everyday square root. So let's talk about what that does and how we do these. These aren't very complicated and should be okay. So we're talking about the square root of 25. So when I do the square root of 25, I want to just split it up into a couple things. So remember, that's going to be the square root of, and 25 is, of course, 5 squared. And x to the fourth is going to be an x squared and an x squared. So you can break it up. You don't have to break it up. It doesn't really affect it. But the square root of 5 squared, these would cancel, and I would just get the 5. So this guy would come outside. He becomes a 5. This x squared and this square root sign would cancel, so he would come outside and become an x. And this x squared would come outside and he would become also another x. So my grand total would be 5x squared. So when you think about it, this square root sign, which has an imaginary 2 here, one that we don't write, I can really just take the 4 and the 2 and say, you know what? 4 divided by 2 is worth 2, so my answer outside is going to be x to the second power. This is just going to take half of that. How many of these can I make out of 4? I can make 2 of them. There you go. So what would that look like over here? Well, over here we have an index of 5, and we have a radicand that's quite a bit larger. So the radicand, that's the number that's actually inside of the root sign. So if I did this, I'd be looking at, since it's a fifth power, a fifth root, I need fifth powers. So what if I broke this one into powers of 5? So instead of 32, that's going to be 2 to the fifth power. It's the same thing as 32. And I have x to the 15th. Well, wouldn't that be x cubed to the fifth power? Isn't that 15 also? And y to the 20th, wouldn't that be y to the 4th to the fifth power? So these things can help me. Since it's a fifth power, all of these are going to cancel. So this 2 is going to come outside, and it's going to become a good old-fashioned 2. This x cubed is going to come outside, and the 5's cancel. I'm going to get x cubed. And this y to the 4th is going to come outside, and I'm going to get my y to the 4th power. So once again, 15 divided by 5 is 3. 20 divided by 5 is 4. Worked well. All right, my last one over here is a cube root. So same issue, same idea. Let's do it. Square root, or cube root, sorry. So I need the cube root of these numbers. So 27 is, of course, what number to the third power? 3. And 6 means I'm going to, how many make x cubes, or excuse me, I can make 3 x squareds. So, I can make 2x cubes. That's good. So this comes outside, it becomes an x squared. This comes outside, it becomes a 3. And I'm going to get 3x squared. So once again, 6 divided by 3 is 2. That one seems to make sense. And that's it. Not too complicated.